The intention of this video is to be an introduction to the BlinkScript node and BlinkScripting in general. If you're coming at this from an absolutely blank, zero experience with BlinkScript, don't even know what the node is before, that's perfect. That's exactly where we're starting from with this. I'm also specifically tailoring this to a sort of artist perspective towards BlinkScript. So if you perhaps got a background in computer science, or you're a comp engineer or a comp TD, then it's possible this may in some areas be perhaps a little bit rudimentary for you, but I think this will still at least be a great springboard to accelerate you into just that initial friction with BlinkScript. So what exactly is BlinkScript? The official, slightly less artist-friendly description for BlinkScript on the Foundry Blink reference guide is: the Foundry's Blink is a C++-like language designed for rapid image processing. It uses standard C++ syntax with a few keyword changes. The way I would describe it from an artist perspective is that BlinkScript acts as the bridge for being able to write directly to pixels. So if you're familiar with working with Python, you'll know that using Python in Nuke generally takes the form of perhaps navigating the node graph, dealing with file paths and things, changing, doing batch changes on knob settings on nodes, automating things, stuff like that. And it's less about actually affecting the pixel. Similarly, Nuke's expression node kind of works the other way around, where it's very, very good for immediately changing the values on pixels, but it's less about actually having that programmatic approach. For example, you can't loop over pixels or create huge amounts of variables that all talk to each other. It's got that limitation of about 4 in the top. So let's jump into a few examples of where I've used BlinkScript for various different tools and why I've used BlinkScript for them, and then we'll jump into getting started. So I've got 3 tools here that I use BlinkScript for because I really couldn't do these tools any other way. I had to use BlinkScript for them. So the 3 of them are GodRaysProjector, Chromatic Blink, and RadialDilate. So let's just jump in to see what they do. GodRaysProjector is a tool that allows you to, using 2 cameras, one to view through and the other sort of like a projector, you can create a GodRays-like effect within a region that we're viewing. So if I just set this to more of a default look, just give me a second, you can kind of see what's going on here. So if we just give this a second to process, you can see that it's generating these it's generating lots and lots of different versions of the input image, this noise, in order to then sort of average them together and create this sort of box of fog. It's a sort of 3D version of the GodRays tool. And so the kind of processes that BlinkScript's being used for here is to loop for every single one of these steps. Additionally, it's doing some translation based on some internal maths using the 2 cameras' positions and rotations and fields of view in order to generate this image. This is perhaps a little bit too complicated to jump into the inner workings of, but the concept is there. Similarly, I have a tool here called Chromatic Blink. So the process this is doing is sort of an iterative ST map effect, where I've got my my ST map here, and I'm applying a transformation to it. And then what the BlinkScript node is doing is it's iterating between these 2 ST maps in order to generate these cool effects. And the reason it's got 2 is so that you can affect the in and out separately and get all of those interesting results. Additionally, you can see that this is responding really quite quickly, and that's because BlinkScript enables you to actually write your script to be able to run on the GPU. By running on the GPU, it means that the whole image can be processed much faster, as GPUs are kind of built for this entire screen-wide sort of parallel operations. And then finally, there's a tool here called RadialDilate, and this is a radial version of Nuke's standard erode fast node, which allows you to dilate your image in and out with a sort of very square filter. RadialDilate does the exact same operation, but with a radial filter. So you can see that the world is your oyster once you really start diving into the world of BlinkScript. You can write whatever pixels you want as long as you can. If you can think it, you can blink it, I think I said once, and that quote is as true as it is cringeworthy. So let's jump into actually using the BlinkScript node. What I'm going to do is I am going to just type BlinkScript here and bring in the blank BlinkScript node. And then the main thing that we're going to be interfacing with is this kernel source tab here, and this is just where all of our script is written. And you can see that this doesn't come in blank by default. This actually comes in with a pre-written example. So let's show you what that example actually is, because it's good to be able to go in, see the example and use it. By default, it is a saturation kernel. So you can see here, I'm able to pull and push my saturation here, and this saturation is a sort of a replica of the Nuke saturation node. Internally, they are using the same maths. However, unless every single Blink project that you're going to be doing is a saturation node, this default should probably be replaced. So how do we do that? Well, in order to do it, we really have to go in and see what each of these segments is doing and determine what we want to keep and what we want to get rid of. So what I'm going to do is I'm going to control double click on this to bring it up full screen. And we're just going to go through this sort of almost line by line, say what's happening and what we need. Rather conveniently, this has been commented, which is great, but let's go through this anyway. So at the top here, you can see that this is calling itself a kernel, and the kernel's name is saturation kernel. So this is already something that we perhaps don't want to have as our default, because again, we don't want it to load in with that name. So I'm just going to perhaps call this blank kernel, so that we know when this loads up that this is blank. The image computation kernel is set to pixel wise. There are two options that could be here: E pixel wise and E component wise. Already this sounds a little bit unfamiliar and overwhelming. The way I like to think about this is pixel wise will go through the image with each pixel, and you can call each of your red, green, blue and alpha channels individually and mix and match them. The alternative, which is E component wise, will run your script on a channel by channel basis. So it will run for your red channel, then your green channel, then your blue channel, then your alpha channel. Very rarely do I find myself in a situation where my scripts don't have channels communicating with each other, so I like to leave pixel wise as my default. Here we have the image section, where we are reading in our source image, which is the input, and we have the DST, so our output image. Again, the default on this is fine, and we're going to talk a little bit more about these options here later. Next, we have the parameter section. Now, the parameter section is where the actual sort of sliders and boxes and knobs that the user will actually change and access is available. So for now, if we were creating a default tool, we would actually have this be blank. So I'm going to get rid of this. Now, the local section, this is where the variables that the user aren't going to be interacting with, just the things that you need for the processing and calculation in the background. Again, by default, we don't need any of these. The define section, that is where we define the name and default values of our parameters. Again, by default, if we have no parameters, we have no need to define them. Now, the init section, this is the stuff that will run before the actual rest of the script. This is the initialization of everything. And again, if there's nothing to initialize by default, which there isn't, we don't need this bit. Next up, we have our actual process section here. Now this is where the magic happens. Sort of 90% of the code I write will end up in this section, because this is where we actually define everything that happens within the script, all of the expressions, all of the looping, all of the, even writing the final image in this line here happens within the actual process. So again, we don't need this line here. We don't need to handle any of this stuff. We don't need to calculate the luminance of what we're working with, nor do we need to apply the saturation. And finally, we don't need this line in this form. By default, I like to have my my sort of blank BlinkScript node just output the input. And the way we're going to do that, and we're actually going to write our first bit of BlinkScript together here now, is we can see up here that our image is named SRC, short for source. And now we're going to say that our source, and remember to put the brackets at the end, is equal to our destination, or our destination now equals our source. And now when we click recompile on this, you can see this has changed to blank kernel. We have no kernel parameters available. And now when we view this node, the output is equal to the input. And then what I would recommend you do is I would recommend that you go and create a new toolset for this, and perhaps let's call this blank BlinkScript. And that's what I always do. I've got one here, one for demo purposes and one for using. But there we are. So this now, it's not a very impressive BlinkScript, but it is a functional BlinkScript. And that is an achievement all on its own. Now, in order to actually get into moving forward and creating any kind of BlinkScript that your mind can imagine, we first have to talk about all of the different variable types that we have within BlinkScript. When jumping into the BlinkScript variables, it can initially seem a little bit overwhelming, which is why I've done a side-by-side comparison between the BlinkScript variables and variables and sliders that you've probably used almost every day in your normal Nuke day-to-day operation. So let's jump in to this little BlinkScript I put together, which has an example of all of the variables you could possibly need. So let's start from the top. I put these into the parameter section because these are variables that our user will be exposed to. And just a little teaser as to what that is all going to look like. You can see it here. Additionally, there are a couple of variable types that are in the local section, because these do not actually have a user-facing representing knob. So let's start from the top. The first one is bool. Now you'll know if you've ever typed a variable type correctly or incorrectly, because it will turn blue. Now those of you familiar with Python will be used to when you write a variable type. For example, if you were to write a string, you would just do something like my string equals, and then you would put it in quotes and say words, and Python will see that, pick it up, and understand it. In BlinkScript, because it's a C++ similar language, you have to specify the type of every single variable, and that comes with lots of gotchas later down the line, but it is what it is. So remember, if you think you've typed it right but it's not blue, you haven't. And so what we've got here is we've got our variable name, or our variable type, sorry, and our variable name next to it. So the first one is bool, which is a boolean. Now this just normally takes the form of a standard checkbox like this. We use these all the times for disables and things like that. We've got int, which is just a single box with an integer in it. No decimals to be seen here. int2 is the same as int, but it comes with 2 settings. So this can be good for, and I've got some Nuke native examples of all of these later just to clear it up, but this can be good for UV grids and things like that. int3, you might be seeing a pattern here. It's just 3 integers altogether, so that can be good for when you're dealing with things like XYZ in 3D space. If you had to define something with an integer in that world instead of as a decimal, you can. And then int4 is the same thing, but with 4 variables. Now float, I use these all of the time because the float options are not only great for sliders, but float 3 and float 4, and we'll get onto this in a second, often take the form of color inputs. So standard float slider, it could be anything. It could be a multiply on a gain operation or a grade operation. It could be anything. Floating point sliders are everywhere. Float 2, this can be really great for dealing with pixels on the screen, as they often come as a decimal. You know, when you do a transform, for example, that has the option to work with decimals. That's what filtering is all about. Float 3, takes the form of this sort of XYZ looking thing, but if we were to, for example, create a color wheel and set this to be RGB, not a color wheel, sorry, a constant, and set this to be RGB, which it is by default, that has got these 3 XYZ values. And then finally float 4, and I think float 4 is probably one of the most powerful variables available. Float 4 is great for RGBA, and by default it even comes in as an RGBA slider, which is fantastic. Now, this is where it gets a little bit exciting. Now we have float 3x3 and float 4x4 there. That's very tricky to say. And these take the form of these sort of grid layouts. These are our matrices. Now these have plenty of great uses as well that we will get onto in a second. And then finally, we've got our array options. You'll see these brackets exist here. They can also take the form of, they don't have to be double brackets, they can be single brackets. So for example, I could call this second array, and then you can put square brackets like this, and then the numbers in the boxes specify the items in the list. So for example, if I did array 12 here, that will have 12 boxes inside of it, or 2x3, these multiply together. So this, for example, would be 6. Now, these don't have a human interface option here. These often just exist in the background, but these can be absolutely amazing. For example, if you wanted to do something that sorted all of the pixels on your screen, you could store them all in a sort of XY array like this, and then run a process that would sort them by a value, reshuffle that array, and then output that difference. Now, when you view it like this, it can all seem a little bit frightening. However, most of these options do actually have a Nuke equivalent on the menu. So let me just pop that up now. And you can see these are just using Nuke user knobs, and they all have got a familiar look to them. So when you start to see them side by side, they seem a little bit less frightening and a little bit more familiar. Now I'm just going to go through a few of Nuke's native nodes to look at all of the different variable types so that we can see them in a familiar context. So for example, on the grade node, if we were to be building this with BlinkScript, a Boolean might be our black clamp buttons or white clamp buttons. A single float variable might be our various different gain sliders. A standard float variable might be this luminance slider or the mix slider. And then these are all float 4 variables because they have 4 parameters to them. Now a float 2 could be really great for a corner pin, because although these, when you move them by default, do round to the nearest integer, they can accept decimal values to be in between pixels. A float 3, and I touched on this before, would be an RGB constant. A standard int would be specifying the UDIM on a UV tile node, and then the U and V, because these are always absolute, they're not decimals, would be an int2. You could store this as a single variable. And then a float 3x3 would be great for making an internal color matrix. This can be really great when dealing with data passes, for example, position passes or normal passes from CG. And then the matrix by default loads in as a 3x3, but when you create a matrix node, just like we did before, you can create these to be any size. So if you wanted to do a matrix operation, which can be very important when you're dealing with filtering, this is the variable for you. But there we go. So we've created a blank BlinkScript node. We've kind of explained what can be possible, why a BlinkScript is useful, and the niche that it occupies and has a sort of unique dominion over. And we've also talked about the variables that you can use in order to work with a great BlinkScript. Now, the second part to this is going to be going from 0 to a finished BlinkScript project. We're going to do a very simple defocus tool that you can control with an input image.